Hey, everybody. Today we are going to be talking about concentration. What is concentration and how do we express it? So, let's start with what is concentration? Concentration is an expression of how much solute is dissolved into a specific amount of solution. Remember, solute is what is being dissolved, and the term that you might also hear is solvent. Solvent is what is doing the dissolving. So, if we're talking about like salt in water, salt dissolves in water. So, salt is the solute and water is the solvent. And when you mix them together, they make what is called a solution. Okay. So, concentration is just an expression of how much salt is dissolved into this solution. And so, because of that, concentration is often represented as some kind of solute amount divided by some kind of volume amount. So, we're going to be looking at two main types of concentration today. The first one is molarity. Molarity is expressed as the number of moles of solute, so how much is dissolved into this thing, divided by the volume of solution in liters. Okay, so it's the moles of solute divided by the liters of solution. We've got an amount of solute and we've got a volume on the bottom. Okay, so let's look at an example of this. Okay, so here's an example problem. It says, what is the molarity of an aqueous solution containing 4.5 moles of glucose in 1.5 liters of solution? So our molarity equation is moles of solute divided by liters of solution. Now, in this problem right here, I am given the moles of my solute, in this case glucose, and I have my volume of my solution. So I'm just going to plug these in. So my molarity, which is commonly represented with a capital M, is 4.5 moles of glucose, C6H12O6, divided by 1.5 liters. Now, if I plug this into a calculator, I'm going to get this is equal to 3 moles of glucose, C6H12O6, over 1 liter. Okay. Now, there's a few ways to represent this. You could also see this as 3 moles slash liters. This is 3 moles per liter. But what's more common is this mole unit and this liter unit will get absorbed into what is our new concentration unit. Because molarity has an agreed upon formula, moles of solute divided by liters of solution, it's more common to represent this as 3 molar with a capital M, and then whatever substance we're talking about, C6H12O6. So if we were in a lab and we were talking about this, we would say that this is a 3 molar solution. And I would have an agreed upon understanding that for every 1 liter of solution that you use, you're going to get 3 moles of glucose. So this is the first one, molarity. Let's look at the second one. The second one we're looking at is called parts per million. Parts per million is used for any kind of concentration that's really, really, really small. Because in parts per million, what we're talking about is how many particles of solute would you get out of a million particles. Okay, so there's an agreed upon formula for parts per million as well. It's the grams of solute divided by the grams of solution times 10 to the sixth. So let's look at an example problem. A solution weighing 3,500,000 grams was found to contain 18 grams of calcium carbonate. What is the concentration of the solution in parts per million? So, our parts per million equation is grams of solute divided by grams of solution times 10 to the 6th power. I've got my solution right here, my solution mass, and I've got my solute mass right here. You can tell that this is the solute because it says that the solution weighs 3,500,000 grams, and it contains, in this sentence, contains implies that this is the solute. So I'm going to plug these numbers in. Parts per million is equal to 18 grams CaCO3 divided by 3,500,000 grams times 10 to the 6th. Now, if you plug this into a calculator correctly, you will get the right answer. But me personally, I like to try and simplify this. So to do that, I'm going to rewrite the denominator in scientific notation. So that's parts per million is equal to 18 grams CaCO3. I'm leaving that the same. But on the bottom, I'm going to write 3.5 times 10 to the 6th grams. And that's just me converting this into scientific notation. If you need help with scientific notation, check back on my video on scientific notation, or you can always ask me in class. Okay? So I've rewritten my denominator. I need to add my times 10 to the 6th. Now, because I have 10 to the 6th on the top and also the bottom right here, math says I can subtract these exponents. So 10 to the 6th minus 10 to the 6th, 6 minus 6, both of these become 0. So they cancel out. And I'm just left with 18 divided by 3.5. So my answer, if I plug it into my calculator, 18 divided by 3.5, my answer is 5.14 ppm, which is parts per million, CaCO3. Now again, just like on molarity, parts per million has an agreed upon formula, grams of solute divided by grams of solution times 10 to the 6th. So when you follow those requirements, your new unit becomes parts per million.